little circles. Okay. Now, if I have multiple functions, let's erase that part here. If I have multiple functions, I'm going to rotate the outer one. I have an inner one, so I'm going to have this hollow area in between. Okay. So I've got this function here, y equals x squared plus 4, and y equals 2. We're going to go about the x-axis, and we're going to go between x equals from 1 to 3. Okay, so again, I like to be able to draw out a picture just so I can visualize what this looks like. So here's my x-axis. I'm going around here. Okay, now let's see, I'm going to go 2, 4, 6, 8, 10, 12, 14, minus 2, 4, 6, 8, minus 10, minus 14. Okay, so now when I go to plot this, the first thing I'm going to do is I'm going to go plot equals y equals 2. So here's one of the graphs. This is y equals 2. And then I need to plot my y equals x squared plus 4. Okay, so I've taken my whole x squared, my parabola, and I've shifted it up by 4. So it's going to look like here. Let's see, and we're going to go from 1, 2 to 3. Okay, so from 1 to 3 is the shape that we're going to be rotating. Okay, so it's going to look like here. This one's going to go here. This one's going to go here. And then here. So our parabola is going to look like that. And I'm just going to draw the mirror image of it down below. So I've got this y equals minus 2. And I've got my shape that looks like, roughly speaking, like this. Okay. Now I'm going to take this and I'm going to rotate it around my x-axis. So I've got this circle, but remember I'm also rotating this bit around here. And I'm going from 1 to 2. So I'm going to draw this like from here. Oops, sorry, I drew it this way. I've got my inner circle. And I've got my outer circle. Okay, so the thing that I'm generating the solid from is this bell-shaped, but it has a hollow portion on the inside that's bounded by y equals 2 and y equals minus 2. Okay, so I'm rotating around the x-axis right here. Okay, so now I have to be able to calculate my outer radius, okay, which is going from my x-axis to my top function, and my inner radius, which is my y equals 2 to my x-axis, okay, because I'm rotating around the x-axis, okay. So I'm going to think about my r, my radius outer, is going to look like y equals x squared plus 4, and my r inner, my radius inner, is equal to y equals 2. Now the volume, when I have two different radii, I've got an outer radius and an inner radius. So you can think my outer radius is the big solid, and I have to subtract out the inner radius here. So I have an outer circle and an inner circle. I calculate the area of the outer circle, and I subtract out the area of the inner circle. So it looks like pi, I'm going to go from 1 to 3, because I'm still doing areas of circles, r squared outer minus r squared inner. And dx is how we're doing. We're going to slice this along the x-axis. Be really careful. This is r squared outer minus r squared inner. It's not r outer minus r inner squared. It's r squared minus r squared. This is the outer circle minus the inner circle. Because we're going to plug things in. Pi 1 to 3. My r outer, x squared plus 4 squared, minus my inner squared. And this whole thing is dx. So this I have to FOIL out to come up with an equation. And this I'm just going to square. It's a number. So I'm going to save you some of the algebra, and I'm going to write to you what it looks like. If you want to see some of the algebra, you can check out the lecture notes that I have posted online. X to the 4th plus 8x squared plus 12. So I squared this part, and I subtracted this part already. That's where the 12 comes from. dx. And I'm just going to integrate using our power rule. So we're going to get volume equals pi times 1/5 x to the 5th plus 8/3 x cubed plus 12x. And we're going to evaluate that from 1 to 3. And when I add in all the numbers and I subtract out things, I'm going to get 2,126 all over 15 times pi. And that gives me the volume of this curve going from 1 to 3, okay, with this hollow spot on the inside. Okay, this is our washer method because our shape that we're doing has like a hollow portion, like a donut on the inside. Okay.